Hello everyone. So in this video we would see how to implement a breadth first search algorithm using Python. So breadth first search, in short BFS, is an uninformed search algorithm, and it traverses a particular graph level by level, and it follows FIFO data structure like FIFO method, which generally used in queue data structures. Okay, so this is the graph we have in here where and this is the adjacency list representation of this graph, where we'd see B and C is connected to A, D and E is connected to B, F is connected to C, and D, E, F is our leaf nodes. So as I said that we would use queue data structures, so for that we have to import DQ functions from collections. So collections, we import DQ. Now let's write the function, define BFS. We would pass our graph, also our start node and our goal node, and that's it. Now let's write the code. First we have to initialize one set, blank set called visited. Okay, then in queue variable I'll simply take my start node, mean my source node, and I'll initialize one blank result array, okay, where I'll put my all path values. Now simply while queue, here I'll take a variable node where I'll simply use pop left from dq, mean in our queue we will pop from the front, because queue has front part and rear part. So in queue we would pop from the front part, so pop left. Okay, then simply we have to check if this node is equals to our goal, then simply result dot append our node, and then simply return our result. Okay, now another thing is, if our node not in visited, okay, mean our node, like the present node is not visited. Okay, so for that we have to create a function, and here we'll simply add that particular node into our visited array, then simply result dot append node, and here I have to extend my graph, I have to extend my queue as well. So queue dot extend, I'll simply call my graph with node, and that's it. This is the BFS function you'd need. Okay, then let's say if I define main function, and if I simply define, let's say a to, and my goal, let's say I'm giving it f. Okay, now we have to see what's my function is returning. My function is returning an array in result. So do path should be BFS, pass our argument graph start goal. Simply if path is true, mean if there is something in the path, we'll print this, else we'll print key, path not found, simply. Okay, now we have to create an entry point for our function. So name main, and this is our entry point, our main function. Okay, now let's run this, the graph and this. So a b c d f, this is my BFS traverse path. And now let's see with the graph. So a, it first traversed the first level, then BC our second level, then DEF our third level. So it traversed level by level from left side to right side. So the answer is A B C D E F. Okay, thank you.